Okay, I hope you can see the shared screen now. Okay, the set of notes that we are using now is number 83. Okay, I hope you can hear me. If you cannot hear me very soft, you just increase your volume. Okay, so okay, wait give me a minute. I don't know why got so many people pop up. Okay, the title for today's lesson is called Aqueous. Okay, I hope you know what's the meaning of aqueous. I think we explained it in the previous lesson. Okay, so the title here is aqueous. It's not the same as molten. Okay, let's go to the first point. Okay, on the first point, you will see I give you a comparison. Okay, I give you a comparison. So the first one is molten. Okay, the state symbol is liquid, and the second one is aqueous. The state symbol is AQ. Okay, so if you look at the examples given, both are NaCl. Okay, both are NaCl, so you're correct. But however, the molten one will only have 2 ions present because it's a binary compound. Okay, but however, if you take the NaCl and you dissolve in water, you have more than just the 2 ions. You have water involved. So when you have water involved, you have H plus and you have OH minus. Can hence hence speaking this, it will also mean that the state symbol is very important. Okay, can Okay, let's begin. Okay, point number 2. Point number 2, we are focusing on cation. Okay, so now the tricky part is there are so many ions involved. Okay, previously there's only one cation and one anion, and I definitely know that the cation will go to the cathode and the anion will go to the anode, one each. But however, if I have an aqueous solution, I have more than one cation, I will also have more than one anion. So this is the part that the problem is. Okay, which one will actually go through the reaction? It depends on this thing called the ease of discharge. Okay, I circle it already. It's called the ease of discharge. What is ease of discharge? Ease of discharge means which is the one that has a higher preference. Let me just write down. Higher preference to take in electrons. Okay, so when you take in electrons, means you gain electrons, means you undergo reduction. Okay, RIG. Yes. So which one is more likely to be reduced? So if you look at the list over here, this list you need to memorize, of course. You need to memorize, but it's very easy to memorize. Okay, you already memorize already. This one is the please stop calling me a zebra. I like her calling. The me is Mercury. Mercury is I think it's HG. Mercury, super guy. Okay, so actually you know the list already. Please stop calling me a zero. So by common sense, you should also know that although it's possible to form potassium metal, that means potassium metal by potassium metal. Okay, this one take 1 electron, gain 1 electron will form potassium metal. Although it's true that the K plus can take 1 electron to form a potassium metal, but you must understand I have water present. You will never see potassium appearing inside water, because if potassium really appear inside water, it will explode. Okay, I think you study group 1 before. Group 1, the reactivity. Potassium is very reactive. You touch water, you explode already. So if you do electrolysis, you will especially with aqueous, I repeat, with an aqueous solution, by common sense, you will never see potassium coming out. Okay? Because it will never happen. If it happens, it will explode. Okay, okay, so this is the least chance to discharge. Okay, so the ease or the chance of discharge will increase all the way to the right. Any questions so far? This you must memorize. You must know which one is the confirm cannot happen one. Okay, potassium is confirm cannot happen. Okay, let's move on. The next one is anion. Anion also have a list of anions because may have more than one anion trying to go to the anode. So which one will be the one that goes to the anode to release away the electrons? Be based on size. Okay, the reason is because the bigger one, the larger anions are more stable. More stable it means not good. Okay, it means that it will not react lah, basically. If it's unstable, then yes, then it will react, and then it will give you the electrons because I need the electrons to go around the circuit. Okay, but if it stays stable, then it will not give out anything. It will stay put. It will not release any electrons. So the stable one means not good for us, for in terms of electrolysis. Okay, so this one is very stable because it's very big. You look at the number of oxygen, you know it got 4 oxygen. The size is very, very big. So sulfate is rarely discharged. Okay. Yeah, but on the other hand, hydroxide, there's a very high chance, easy for hydroxide to discharge. Can based on size, because yes, the bigger, the more stable. Okay. And more stable means less likely to be discharged. Any questions so far? I need to discharge it, then I get the electron come out. Then the electron can flow to the other end. Okay. Okay, the next thing I talk about cation, anion. The number 3 is concentration. Okay, because this is a solution, aqueous solution, not the molten one. The molten one don't have concentration one. It's just the solid melt. This one is concentration. So it depends on how much salt that I put inside the water. I can put a lot of NaCl. I can only put one drop of NaCl. It depends on how much NaCl I put. So the concentration can also affect the whole story. Okay, so basically how it affects is that if I have a high concentration, then that ion will stand a higher chance. Okay, I give you an example. If you compare Cl and OH minus, based on the size, okay, Cl very hard to be discharged. Okay, but however, if I have a lot of Cl, then Cl will be the one that will be discharged. Okay, preferentially discharged. I repeat, usually you won't see Cl minus discharge one. You'll see hydroxide because that's the easiest to discharge. But let's say I put a lot of NaCl, so much so that the whole beaker is full of NaCl. So I have a lot of NaCl, then the chance of Cl discharge will be higher. Okay, so the concentration will affect the story. Okay, the next one is electrode. The electrode also affect the story, but this one we will not talk about it today. It will be your next cell notes. Any questions so far? Can got question better ask me. Okay, so our focus today is about aqueous solution. That means things that are dissolved in water. Okay, but however, as I mentioned, the concentration plays a role. So we will explore 2 situations. One is when the aqueous solution is dilute, whereas the other one is concentrated. I hope you know the difference between the two. Dilute means I dissolve a little bit only. Concentrated means I dissolve a lot of it. Okay, so over here both are sodium chloride. Okay, I have sodium chloride dilute one, I have sodium chloride concentrated one. Okay, the picture may look the same, but however, let me point to you the difference. Okay, the difference is this one highlighted in yellow, or maybe I change color lah. Highlighted in green. Okay, the difference is highlighted in green. You will see that the concentration will actually affect what you get as a product of electrolysis. Okay, then later I'll explain why the difference. Okay, so over here, for sodium chloride, let's look at the dilute first. Okay, but first of all, before we even begin on step one, it's also always a good habit to ask yourself, what are the ions present? Okay, so because this is an aqueous solution, is an aqueous solution, I will have two cation ions and two anions. Logical, because one of the cation is sodium, coming from sodium chloride, the other one is from water. Correct? Okay, so sodium chloride, same, I will have two anions. One is chloride and one is hydroxide. The hydroxide comes from the water. Can, so far so good. This is the first step. You must think of what are the ions present. Okay, then we continue with the story. Okay, step two, you realize step two, I highlight the yellow box, means complicated. Okay, so for step two, let's look at the cathode. Okay, CATHODE. And this is the anode, ANODE. Okay, sorry, my bad. Both are cathode. This one also cathode, this one also cathode. Okay, but this one is for dilute. This is for concentrated. Okay, so this is the difference. Both are at cathode, but I'm trying to see what happens at the cathode. Okay, one is for the dilute, one is for the concentrated. Okay, so first of all, if you are looking at cation ions, we look at this thing. Where's that thing? This thing. Point number one, this one. Okay, for this, concentration is not going to affect this. I repeat, concentration only affects the anion. And you go and write it somewhere. Concentration, the effect of concentration only affects the anion. Okay, can. So over here, I have two cations, Na plus and H plus. Similarly, for concentrated, I also have Na plus, H plus. Okay, because they are both present. But however, I think okay, now this one done. Okay, they are Na plus and H plus. Okay, so what happens here is, if you look at this thing, as same story, sodium will not appear. If you appear sodium metal, it will explode also. So over here, I will discharge H plus and the Na plus will not discharge. Okay, so my H plus is the one that will go towards the cathode. So imagine the H plus ion moving and moving, you will move towards the cathode. So when you move towards the cathode, it will collect the electrons from the cathode. The cathode has all the electrons. Okay, so you collect all the electrons from the cathode plus electrons, and you'll form H2 gas. Okay, this one is a shortcut. Or what is happening is H plus one electron will give you H. Okay, then include a state symbol. But however, because hydrogen gas is diatomic, so it needs H2. So I have 2 and I have a 2. So it becomes 2H plus 2E, give me H2. Then include the state symbol. Hydrogen is a gas, so the state symbol is G. Okay, any question? So you will imagine that all the H plus will go to the cathode. The Na plus will stay put. The Na plus will not move. As in, it will still move inside the solution, but it will not move towards the cathode. Okay, so the Na plus are still flowing around, just that it will not flow towards the cathode. It is the H plus that will flow towards the cathode. Any questions so far? Okay, for the concentrated, also same story. Because the H plus is easier to discharge, the H plus will go towards the cathode. Same reaction will happen. Everything the same. Same. Okay, everything here is same. Okay. Okay, step three. Step three, let's look at the anion. The story for anion. Okay, anion. So for anion, we'll look at the anode. Okay, this is dilute. And that is concentrated. Okay. Okay. Now since we are looking at the anion, the concentration will come to story. Okay, so over here, but before that, you must understand there are two anions. Okay, there are two anions. For the dilute one, this will be the one that's discharged, OH minus. This one will not. Okay, why? Because of this chart over here. Yeah, this one is the easiest. Okay, it's written that way, easiest. So for this one, I will put the OH minus take, it will discharge the OH minus for dilute. But however, for concentrated, it's a different story. For concentrated, they will prefer to discharge Cl minus. Can? Any questions so far? Okay, the very important words are in red. So in concentrated solution, that means there are a lot of Cl minus. Okay, you will discharge the Cl minus instead. Can? Okay, this one unfortunately you need to memorize. So when the OH minus goes to the anode, when it reaches the anode, it will release the electron. That's why the electron come out. Okay, so when it release the electron, what will it become? It will not become OH. There's no such thing called OH. Okay, the OH will reform into H2O and oxygen. Okay, so let me take my eraser. Okay, so the 4OH minus will go to the anode because the anode attracts the anion. Then you'll form water, oxygen, as well as your electrons. Then this electron will pass over all the way to the cathode. That is definitely what happens when you have a hydroxide going over to the anode. Okay, and of course the Cl minus will just keep swimming in the electrolyte. Okay, it will still moving, it will still flow around in the electrolyte, but it will not flow towards the anode. Okay. Okay, on the other hand, the concentrated one, I have a lot of Cl minus. So the Cl minus will be the one that goes to the anode. And when it goes to the anode, it must donate away the electron because the anode is the electron production site. Okay, it will produce all the electrons so that all the electrons can go to the cathode. So Cl minus, when you go there, every Cl minus will become Cl plus one electron. But because Cl is diatomic, okay, group 17 start atomic, so you put a 2, then you put a 2, everything put a 2. This is the equation that you get. It's oxidized. Okay, can? Any question? So far so good. Anybody very confused already? No. Okay, let's look at this question. Okay, this is an aqueous solution, obviously, because acid, the definition of acid is an aqueous solution. It's a substance that dissolves in water to ionize and give H plus ion. Okay, so acid is an aqueous solution. So now I put acid and I tell you it's concentrated acid. So the concentration effect will come into play. Okay, and we are trying to use electricity to electrolyze this thing. Okay, so over here, it's good that you identify which one is the anode, which one is the cathode. I trust you know this one is the cathode. Okay, because it is minus and it's connected to the minus of the battery. Okay, this is plus, which is the anode, and because it's connected to the plus of the battery. Can because later I'll tell you what I ask you what is this gas, what is this gas. Then you need to know which gas go where because the cathode will release what gas, the anode will release what gas. It's different. Okay, so you need to know which one is the cathode, which one is the anode. Okay, so give the name and formula of all the ions. This one very simple. So for HCl equals, I'll have H plus, OH minus. This is from the water, as well as H plus. and Cl minus from the HCl lah. Can? Any questions so far? But it's the same thing lah. H plus is the same thing. So you can just erase. Okay, you can just erase. So the answer is this. Can? All the ions present is H plus, OH minus, and Cl minus. Okay, explains what happened to each of these ions as it arrived as the electrode. So let's just look at cathode. Cathode attracts cation. So my only cation, or rather the common cation, is H plus. Can? So H plus, what will you do? You go there, you will take electron, right? Or positive must take in the negative electron, right? So when you take in the electron, become neutral. So become H. But because it's diatomic, then you just put 2 lah. Then you just put the state symbol. Can? G, this one is aqueous. Done. Is it very difficult? No lah. I trust you
Teacher,
can do. What?
I thought you say cannot put 2H plus because H2 is like neutral, so there's no such thing as 2H plus.
Yeah.
There's no such thing. Okay, there's no such thing called H2 plus. This one don't have.
But
But
2H
there's
plus and H2 plus is the same thing, what?
no. Okay, 2H plus have. This one have. Okay, what's the difference? H2 plus is bonded. This H2, this H2. So when you bond means what? When you bond means you don't have negative and positive. It's covalent bond. It's covalent bond where got charge one. Covalent is never lose or gain electron one. It's share electron. So where got such thing called plus and minus in covalent one? Don't have, right? You should know. You should know. Only ionic got ion got plus and minus. So there's no such thing called H2 plus. But there's such thing called H plus. You know H plus. And 2H plus means I have 2 sets of H plus. Can the H2 is hydrogen gas. It's a covalent bond. Covalent bond will not have charges one because they share electron. They don't lose or gain electron. Okay,
Okay,
so
thank you.
don't remember wrongly. Okay. What else? Anode. Okay, so for anode, okay, I have 2 things over there because of concentration. The Cl minus will be preferentially discharged. So when you discharge means the electron must come out. Okay, electron must come out. So I have Cl plus the electron come out. Then of course, because chlorine is diatomic, you just put a 2 lah. Then after that, chlorine is a gas, so put G. This one is an aqueous. Then done. This answer. Any question?
Mr. Reef,
Yes.
they ask for give the names and formula. Must you write the name?
You ask for name. Oh yes, then you write the name. Hydrogen ion. And what else? Hydroxide ion. And chloride ion. Okay. Can? So far so good. Okay. Next one. Identify the gases collected in the inverted tube. So how do you identify the gas? That means how you test for gas. How do you test for hydrogen? I think you know. I will not go through, right? Insert the lighter spin, extinguish your pop sound. And then extinguish with a pop sound. Okay, this one you should know lah. How to test for chlorine? Insert moist blue. Then you become turn red. Then after that you become bleach. Can? Any question so far? No question. So far so good. Can? You check the notes. You should know very well. The QA topic just over it. Okay. So yes. So I will not write so long sentences. Okay. Why would steel not be suitable metal for the anode? Okay. Why? Because the chlorine gas, anode is chlorine. The chlorine is produced at the anode. the chlorine gas will oh my bad, it's not chlorine. Chlorine is neutral. So it will be the acid. This is an acid, this is a HCl, hydrochloric acid will react with the iron. Iron is a metal. The iron in steel to produce iron chloride FeCl3 and hydrogen gas. Okay, acid react metal. So I cannot put a metal there and I put the acid there also. Why is that acid? Because I use HCl. I'm doing the electrolysis of HCl acid. So I cannot use steel because like that the anode will react finish. No more anode. Can? So it's not a suitable metal for the anode. Any questions so far? So far, so good. Okay, move on. Can? Okay. Okay, next one, sulfuric acid. Oh, just now is hydrochloric acid. Okay, so now it's sulfuric acid. Okay, so sulfuric acid, everything is same story. Okay, so you have two cations, I have two anions. Okay, why? You know why. Okay. This is the common one, H plus. Okay, next. Okay, so basically step one is to identify the ions present. So just list down what are ions present. Okay, next, I'm looking at the cathode. So cathode, I'm looking at the cation. There's only one common cation. Okay, so there's only one common cation. Then this will be the answer. So the H plus will go to the cathode to take up one electron, become H. Then because it's diatomic, you just double everything. Okay, then you just write the state symbol. So this one, very simple. It's the only ion. Okay, step 3, let's look at the anode. The anode, I have two anions now. Okay, I have two anions. So you compare which one will be the one discharged. So you look at the chart. The chart says that the smaller size easier. So OH is the easier one. Okay, so OH will go through the discharge. And when OH goes through the discharge, you can just go and memorize the equation. It becomes water and oxygen and 4 electrons. Can? Any question? So far, so good. No issue. Then what happened to the sulfate? They will just keep on swimming in the solution. Okay. So now I need to combine the equation to give me this overall. So how do I actually write this overall equation? Okay, this one comes from the cathode. This one comes from the anode. Correct. We just put them together. Align the arrow. Okay, so cathode, you need to times 2. Why do you need to times 2? Because I need to have 4 electrons and 4 electrons here also. The electrons cannot go missing. If the 4 electrons come from the anode and goes to the cathode, it will be the same 4 electrons that end up in the cathode. Okay, so this one got 4. So okay, this one got 2 only. So cannot. So I must times 2. Okay, so the equation from the cathode, this one must times 2. Okay, because this one only got 2 electrons, whereas this one got 4 electrons. So the electron cannot disappear. Okay, so I times 2 to the entire cathode. Then you go and do your math lah. The 4 electron and the 4 electron cancel. Then the oxygen it becomes the oxygen here. Okay, can. Then this is the complicated part. This is the complicated part. Let me change my color. This one means got 4H plus. Correct or not? This one means got 4 OH minus. So total is 4H2O. Correct? So on my left hand side got 4H2O. On my right hand side, I got 2H2O. So 2H2O here and 4H2O here, an arrow, means the net balance, you're going to cancel like 4x and 2x. You cancel, you'll get your 2H2O. Okay, this one a bit algebra, I don't know how to explain, but it's 2H2O lah. Okay, so you must understand where the 4H2O come from. The 4H2O is because of 4H plus and 4OH minus, so together become 4H2O. Then the right hand side got the 2H2O in orange. Then you just cancel, become 2H2O. Then the H2 will just become the H2 lah. You times 2, so become 2H2. 2H2. Any question? This is how I get my overall equations. Okay, why I need to go through this? Because exam will ask you write overall. This one is easy because it's water electrolysis. Okay? Can? Any question? No. No means okay. Okay, this I believe this is the last question already for the day. Okay, so it's the same thing, sulfuric acid again. So for sulfuric acid, you just write give the formula of all, it's not only formula, don't need name. So the ions are, what is this? This is sulfuric acid, right? H2SO4. So I got H plus, I got SO4 2 minus, and I got OH minus. OH minus is from the water. Okay? Can construct ionic equation for the reaction H. Okay, so for cathode is H plus. There's only one H plus only, no other. So H plus 1 electron become H, then everything times 2. Then this is a gas, this is equals. Quite simple. After you write so many times, you know what to do already. Okay, then anode. Okay, look at the ions, you got 2 of them. Then confirm is the OH one. So you either go and memorize 4OH minus. I suggest you go and memorize. Okay, 4Ln minus give you 2H2O plus O2 plus 4E. Yeah. Can? Any question? Can cathode anode done. Okay, test for oxygen. I trust you know how to write for test for oxygen. You insert the glowing screen, then you rekindle. Okay, so I'll not talk about part B. Part B done. Okay, part C, explain why the volume of hydrogen collected is twice as much as the volume of oxygen. Okay, this would mean I need the overall equation. Okay, I need the overall equation. What's the overall equation? You can do what I do just now, go and times 2, then balance, But because it is sulfuric acid, just now my example also sulfuric acid, right? Also sulfuric acid. So I will jump. The answer is this one, overall. Okay, how to get the overall? It's all the thing just now I explained. Okay, so this is the overall equation. 2H2O. Okay, become 2H2 plus O2. If you have not realized, this is electrolysis of water. Okay, because when you pass electricity through water, you really get hydrogen oxygen gas one. Okay, this is actually the electrolysis of water. Then how come it's the same thing as electrolysis of sulfuric acid? That's because the sulfate never take part in the reaction. The sulfate ion are running around. Okay, it's not preferentially discharged. So in the end, it end up only OH minus discharge. So it's the same as electrolysis of water. So it's the overall equation. So why is the volume double? Very simple. Because why is it twice? Because I have the mole ratio. The mole ratio of H2 is to O2 is 2:1 ma. This is the mole ratio, correct? I trust you know the mole ratio. The mole ratio of H2 and O2 is 1, 2:1. So very simple lah. If I have 2 mole means 48 dm cube lor. Then this one is 24 dm cube lah. Plus 1 mole is 24 dm cube. So it's double lah. The reason why it's twice as much because the mole ratio is double. And the mole ratio, you also mean the volume ratio for gases. Okay, for gases, 1 mole of any gas occupies 24 dm cube. Any question? So that's why the picture, you can see the picture is double. Let me check whether it makes sense. So this is plus, so this plus is minus. Minus is cathode. Okay, then this one plus is anode. And then the cathode, I should get hydrogen gas. Yes, cathode should get hydrogen gas. Let's see, is it correct? Cathode, I should get hydrogen gas. So correct, hydrogen is double of oxygen. Yeah, so the picture is correct. It's not wrong. Okay, so the cathode is where you collect the hydrogen gas. And the hydrogen gas will be double the volume of the oxygen gas. That's why the picture shows double. Any question? If not, we are done with the day already. Can anyone ask me any question? Have, don't have? Have, don't have? Don't have, Okay, don't have, I need to stop recording already. Okay, let me stop recording. Stop recording.